Good evening, my dear WBJEE 2025 students, and a lot of you were requesting in the comments of the previous videos asking us to conduct the most expected questions for the West Bengal joint entrance examination. So here we are. I have selected 40 good questions which you should definitely solve. You must solve, must do these questions before entering the examination hall. So this is your captain Shreyas here, and this is one of the first lectures for this particular year regarding the WBJ, which was most sought of from many students. So here it is. Make sure you quickly smash the like button, leave a comment if you're watching it in a recorded mode, and of course, subscribe to the channel as well, because it matters a lot that you show your response, your love, your affection, your respect to the lectures which we are doing it for you, decoding the subject, decoding the questions, just so that you can excel. Right? Hello, Alona. Hi, Yogesh. Hi, Cutely. Hi, Satru, Abhi. Welcome, Eric, everyone. Time to start the session. Now, before we start, let me remind you that there are three categories of questions in WBJ. Category 1, which is like very direct, the easy ones, you can say, they carry 1 mark and negative minus 1 by 4, negative 1 by 4 marks in case you mark it wrong. The second category has 2 marks. There are only 5 questions in it, and negative half mark, which is again 25% negative. And the last category, again 5 questions only, but here multiple correct options might be there, and you will see that you will not get any negative marks, but there is partial marking over there. Cool. All right, perfecto. Okay. Hi, Swati. Sharmila, we have done lot of VIT Triple E classes. Please check Shreyas sir VIT Triple E. You will find lot of classes. Yeah, just search it on YouTube. You'll get it. So let's do some questions here. I will give the remaining questions as homework in category 1. We will also concentrate on category 2 and category 3. Okay? Yes. All right. Let's go with category 1 first, starting off with the first question on your screen. There is a battery whose EMF is E, internal resistance is R, small r, connected to an outside resistance capital R. The condition for maximum power which will be transferred. So if you have this battery and this internal resistance and you connect an external resistance like this, the question is the power delivered across that load, which is nothing but I squared multiplied by R. I want to maximize this. I want to basically maximize this. I want to maximize this. I want to maximize this. This is called as maximum power transfer to the load, maximum power which is transferred to the load theorem, maximum power transfer theorem. And this happens, this maximum power transfer theorem condition states that this happens when internal resistance is equal to the external resistance, then it is going to be maximized. So very simply put, R is equal to R. If you know the result directly, good. If you do not know, then you will be wasting a lot of time. In such cases, avoid such questions. Do not sit and derive theorems on the spot in the examination. Yep, very good. Awesomeness. Let's go. Hi. I cannot read Bengali, so please don't ask me to read your name. If you can type it in English, I would be very happy and delighted to take your name as well. Cool. All right. So let's go ahead, my dear students. Okay. A body of mass 2 kg moves in a horizontal circular path of radius 5 meter. At instant, its speed is 2 root 5 meters per second and it is changing at some rate. The magnitude of the force acting on the body at that instant is. See, this particular body is going in a circular path like this. At that particular instant, the velocity is given, which is 2 root 5 meters per second. But at the same time, there is a tangential acceleration which is given because the speed is increasing at some rate. So the tangential acceleration is given to be 3 meters per second square. Obviously, there will be centripetal acceleration also, which we can find out. And once we know the centripetal acceleration, we can find the total acceleration. We can find the total acceleration, which will be over here. And from the total acceleration, we can find out the net force. So Once the diagram is clear in your head, then it is easy to solve the question. So let's start by finding centripetal acceleration. Centripetal acceleration is the speed square by the radius. Speed is nothing but 2 root of 5, the whole square. Radius is nothing but 5 meters. So it will be 2 square into 5 divided by 5. 5 cancels and I'll be getting 4 meters per second square as the centripetal acceleration. So what is the total acceleration? It is the vector sum of both. So it is AC square plus AT square. The centripetal, I just figured it out, it is 4 and tangential is nothing but 3. This is nothing but a Pythagorean triplet. 16 plus 9 is 25. So the root of 25 is nothing but 5 meters per second square. Once I get the acceleration, use F is equal to ma. Mass is 2 kg. Acceleration is 5. So the answer will be 10 Newton, which is option D, which is nothing but option D. Is this absolutely clear? So the rate at which the speed changes is basically nothing but your tangential acceleration. Cool, everyone? Yes. Hello, Asim. For VIT Triple E, the last class was over. Sharmila, if you want more classes, please Google over here on this channel itself. Just search for Shreyas sir VIT Triple E or just search for VIT Triple E over here and just search for physics or whatever, English aptitude. You will get it on the channel. See, this concepts plus questions, physics questions. Then these are the previous sessions, must do sessions. Okay, all these sessions are there. Okay, just go on the channel itself, it is there. Cool. Okay, moving on to the next question on your screen. Here it is. Get ready, guys. All right. The equivalent capacitance of the combination is what? Well. As you can see over here, this point is common for these two capacitors, and this point is also common for these two capacitors. That means these two capacitors basically are in parallel. They are nothing but in parallel. So the effective capacitance will add. So C plus C will be nothing but 2C. Now this capacitance is in series with this capacitance. So this is nothing but your point P, I suppose. This is having capacitance C. Then the other one has a total capacitance of 2C, and that is then connected to your point N over here. Obviously, they both are in series now. This is in series. So in series, what happens to the net capacitance? It will be C1 C2 by C1 plus C2. So C multiplied by 2C upon C plus 2C, which is nothing but 2C square by 3C. CC cancels, so 2C divided by 3. So 2C divided by 3, which is B option, is the right answer, my dear students. Is that right? Everyone, shall we go ahead to the next one? Today's VIT triple Y was very horrible. Is that so? And I have been warning you guys that suddenly VIT triple E questions just become randomly hard, randomly easy. It's not a predictable exam. I've been warning you. So unless and until you get a really good score, do not enter. Otherwise, there are other entrance exams. Number one, number two, the fees are costly. Number of students are very high in the college. You don't have an individual identity. Plus fees, everything, hostel, everything is expensive. So be very, very careful. All right. So moving on to the next question on your screen. 3 metallic shells are there. A, B, C are the radii, and the surface charge densities are given. What is the potential of shell B? Okay. So if they ask you what is the potential of shell B, it will be due to outer shell, due to that shell itself, and due to the inner shell. So the potential of the shell B will be the potential due to A plus the potential due to B itself, and the potential due to the inner one, which is basically A. Sorry, my bad. C. Due to C, due to A, due to B, and C. Now, if you notice, for A, this particular point is outside the shell A. So potential due to A, and you will use basically nothing but the outside formula. You are outside that shell A. For B, you are on the surface. So this is going to be the surface formula. And for the shell C, this point B is inside. This point B is nothing but inside. So three different things, be careful. The potential due to this particular shell will be as if the charge is concentrated at the center and you are at a distance of B. And you are at a distance of B. So it will be nothing but K into charge on A divided by basically B. That is what it will be. Plus, again, Coulomb constant due to B, you're on the surface. So on the surface, it is just K into charge on that shell divided by the radius of that particular shell, which is again B. Plus, due to C, what will happen? You are inside. So when you are inside, the potential everywhere is constant. So it will be KQ divided by the radius of the shell, which is nothing but C. Radius of that shell when you are inside, yes, that is what is going to come everywhere. Please understand. Yep, everywhere, please understand the potentials will be constant. Is this absolutely clear, my dear students? Is this absolutely clear? Very good. Okay. So now let's start writing down all the things that we can figure out. First of all, K is nothing but 1 by 4 pi epsilon naught. Let's take it common everywhere. You will have something by B over here, something by B over here, and something divided by C over here. What is that something? Charge. Well, what is charge? Charge is nothing but the density of the charge multiplied by the area of that shell, So charge on A will be the density, which is sigma, multiplied by the area, which is nothing but 4 pi A square. Then for B, it is negative, so put a minus sign. So sigma minus sigma into 4 pi B square. And for C, it is positive, so plus sigma into 4 pi the radius square. That is what will happen. As you can see very evidently that 4 pi, 4 pi, 4 pi cancels with this particular 4 pi. And I am left with 1 by epsilon naught, and sigma is also common. So sigma can be taken out as common. And we will have over here a square by b minus b square by b is b, and c square by c is nothing but c. So a square by b minus b plus c, which is D option. As simple as that. Can you see over here? Yep. So you have to use three different scenarios for solving this question. This would be a very good level question if it comes in the examination. All right. VIT Triple E papers are very unpredictable, so there is no point predicting it, and there is no use also because it is completely random. So don't put all your eggs in the VIT Triple E basket. I would suggest give other entrance tests and hope for the best. If you get VIT Triple E, good. That took a top branch without paying much donation, everything, that's fine. A charged particle moving with some speed in a magnetic field experiences some force V1, V2, F1, F2, they are basically the components and constants, then magnetic field will be. Okay, see guys, very simple, that the force which is there is nothing but charge multiplied by velocity cross the magnetic field. This is the Lorentz force formula. So the force is having some components, which is F1 I cap plus F2 j cap is equal to charge into, well, we do not know, no, we know the velocity. Velocity is nothing but what? V1 I cap plus V2 j cap, and you're crossing it with magnetic field. So it will have some B1 I cap plus let's say B2 j cap plus B3 k cap. So that is what I will write it down as. Is this much point absolutely clear? Everybody till this? Yep. Very good. Now I'll tell you one interesting thing over here. Look at the components. Everything is in I cap and j cap. Everything is basically in I cap and j cap. There is no k cap anywhere. Okay. So if you think carefully, if I do this particular cross product, which goes something like this, say I do I cap over here, there is j cap over here, there is k cap over here, I have V1 here, I have V2 over here, there is no k component. For B, it is B1, B2, and B3, of course. So I am not interested in the I cap component. I'm not interested in the J cap component. I am mainly interested in the K cap component because whatever I do cross product over here, there is no K cap on the left hand side. So this K cap should be 0. That is very well understood. So how do I find the K cap component? Ignore this column, ignore this row, multiply this, multiply this. So this will be nothing but V1, B2, and this will be V2, B1, and subtract them. And this entire thing must be nothing but 0. So therefore, V1, B2 will be V2, B1, which also means that V1 by V2 will be nothing but B1 by B2. V1 by V2 is B1 by B2, yes. And B will be B1 I cap, B2 J cap, and B3 K cap. Yes, that is what it should be. So I think B option is the right answer. B option is the right answer because we got this condition right from here. Because there should be no K cap over here. And this is how that particular magnetic field components will look like. Is this absolutely clear, my dear students? Let's go to the next question on your screen. Here it is. There is a wire which carries some current in the xy plane. Y is equal to blah blah blah. Magnetic field is in the z direction. The magnetic force on it between 0 to lambda is. So this equation which you see over here is actually the equation of a wave. If you notice carefully, yes, it is the equation of a wave. So the wire is basically like this. It is carrying some current I over here. Now 0 and lambda. So 0 will be obviously over here. Lambda will be obviously here. This is like a wave equation, correct? A sine that 2 pi by lambda is like kx. So it is like a wave equation. So you have to find the force on this curved wire. We all know one thing, that the magnetic force on a curved wire is the same as the magnetic force on a straight equivalent wire joining the ends, which will be then I into effective length into B. Yes, that is what it is. So the current is basically over here I. Effective length I do not know. Magnetic field is nothing but B. So what is that effective length? Just join the line between the ends. So this is your effective length right over here. So this is basically your L effective. So L effective is nothing but your lambda. So it will be just I lambda B, which is nothing but, I think over here they have made a mistake. So it should be just I lambda B. Yeah, that's it. Is this absolutely clear? Yep, it should be just I lambda B. That is the correct answer. Very good. Okay. There is no way to get those VIT triple E papers because just like JEE Mains, they do not disclose the questions nor their answers. It's not so transparent, guys. Number one. Number two, it's all memory based, so you have to rely on students recollecting something, and the number of questions are heavy, and not many students give VIT triple E, so getting hold of those questions is slightly difficult. Okay, all right. So yeah, if you have VIT triple E tomorrow, will this session help you out? Obviously, because the questions are of physics are of good level, guys. In WBJEE, the questions are not very easy also. The questions are of good level. So definitely it will help you out. In a series LCR circuit, RMS voltage in the resistor and the capacitor are 30 and 90. If the applied voltage is 50 root 2, then the peak voltage across the inductor. So capacitor's voltage is given, resistor's voltage is given, and they have asked what is the voltage across the inductor. So the net voltage also we can see, it is right over here. Okay, so this is basically the peak voltage, the peak net voltage. So what will be the RMS net voltage? It will be nothing but 50 root 2, 50 root 2 divided by root 2, which is nothing but 50 volts. Now we all know that the net voltage which comes out is nothing but voltage across the resistor square plus VL minus VC the whole square. So V net is nothing but 50, or resistor's voltage is nothing but 30, and well, VL is nothing but 90. So sorry, VL is not 90, VC is 90. So we have to find VL. So VC minus 90 the whole square. That is what it is asked. I hope you can see it. Yep. 30 is the volt across the resistor, and 90 is the voltage across the capacitor. Is this absolutely clear? Okay, so what do we do now? 50 square, so that is going to be 2500 is equal to 30 square, which is 900, plus VL minus 90 the whole square. So VL minus 90 the whole square will be 2500 minus 900 is 1600. So VL minus 90, VL minus 90 is nothing but 40, guys. Is that right? VL minus 90 is nothing but 40, because square root of 1600 is 40. So VL will be 40 plus 40 plus your 90. This is one option. And another option I'll tell you happens because there is another root possible. Yes, when you take the square root, this is one possibility. This is one possibility. There is second possibility that 90 minus VL, 90 minus VL is basically 40. Yes, both these are possibilities. Both of them are possibilities. So from here, basically the difference should be mod of difference should be 40. That's all. So here we get VL is nothing but 130 volts. 130 volts. Here we get basically from this particular option. 90 minus VL is 40. So VL will be nothing but 50 volts. VL will be nothing but 50 volts. So the question asked is, what is the peak voltage? So if you calculate the peak voltage over here, whatever we have got is RMS. So you multiply it by root 2. So it will be 50 root 2. Whereas here, if you try to find the peak voltage, here if you try to find the peak voltage, it will be 130 root 2. But 130 root 2 is not in the option, only 50 root 2 is there. So answer is 50 root 2. Okay. I hope this is absolutely clear. Only one solution can be accepted. So one option, whichever is feasible, you are going to mark that particular option. Is that fine, my dear students? Let's go to the next question on your screen. Here it is. There are two straight conducting planes form an angle theta where the ends are joined. A conducting bar is in contact with the plates, forming an isosceles triangle, and at time 0 it starts moving with some speed, which is constant. The magnetic field are out of the page. Okay, the magnitude of the induced EMF at t is equal to 1 second. Okay, so is in contact with the plates, forming an isosceles triangle, starts at the vertex at t is equal to 0. So at the time is equal to 0, at time is equal to 0, this particular rod was over here. So after some time, it is going to probably cover this particular distance. This is, let's say, x over here. There will be some length of the rod which is in contact with it, which is going to matter for calculating how much EMF is generated. We'll come to that in a bit. Okay, so how much distance have you traveled? It will be the speed multiplied by the time. Speed is basically v, time is just 1, so x is nothing but v. Okay, now in order to find the length, one thing is there, this is L by 2, let's say this is L by 2, this is 90 degree, so this is theta. Okay, so you can see that there is theta by 2 everywhere, probably only for this reason that only this much angle will be theta by 2. And if somebody asks me what is tan of theta by 2, I will say opposite side, which is L by 2 divided by x, which is adjacent side. So from this, I will get L by 2 as x times of tan theta by 2. And therefore, L will be nothing but 2x tan theta by 2. But wait a minute, I know the value of x. Just we figured it out over here. X is just nothing but v. So I just substituted the value of x. Now, why did I find the length of the rod which is in contact? Because we have to find the EMF. This is nothing but motional EMF. So this is nothing but the EMF which is created because of motion, which is B L into V. So B is B only. L is nothing but this length. So which is 2V tan theta by 2. Okay, and V is V only. So it will become 2B V square tan of theta by 2. 2B V square tan theta by 2, which is B option, which is nothing but B option. Very, very straightforward. Once you find out the length, before that it was crazy. All right, let's go to the next question on your screen. There is an electric field which is given because of an electromagnetic wave. Everything over here represents normal symbols of a EM wave. Which of them gives me the direction of the magnetic field? Interesting. So we know one thing though, that if you take electric field, and if you take magnetic field like this, magnetic field, they will be perpendicular to each other. Also, they will be perpendicular to the speed of light like this. And if I take the unit vector of speed of light, unit vector of the magnetic field, unit vector of the magnetic field, and unit vector of the electric field, they will form a relation something like this. E cross B is C, or C cross E is B, or B cross C is E. Anything, whichever you like. Here I want to find out B hat. So as you can see, B hat will be the cross product of, check this out, take your fingers of your right hand, align it in C and slowly move towards E. It will point, your thumb will point towards B. So it is obviously going to be C hat cross E hat. E hat is very obvious from here. So, I mean, it will be just taking the vector, it will be I cap plus j cap, whole thing divided by the magnitude, which is 1 square plus 1 square, which is root 2. Okay, fine. I'm not so interested in the magnitudes over here, so don't worry about it. So cross producted with, I want to find out what is C hat. So for C hat, look at this. This is Z over here. That means it is going in the K cap direction, either K or minus K. But when it is minus, it is going obviously in the plus Z direction. So plus Z means it is going in the K cap direction. So once you get that, it is very simple, guys. So what is K cap into I cap? I, J, K. K cross I is basically plus J. So this is nothing but plus J. K cross J is nothing but minus I cap. So the whole thing divided by root 2. So B hat is in the direction of J cap minus I cap. J cap minus I cap is B option, as you can see over here. Yes. So that is how you solve these questions. If you know this vectors, how they are aligned with relative to each other, that's it. Your job is done. Yeah. Okay, very good. So you can use many relations. You can say E cross B is C, just like IJK, same things. E cross B is C, C cross E is B, B cross C is E. So whichever vector you want, accordingly you can solve it for that. Moving on to the next one. The position of the center of mass of the uniform plate as shown. Okay, so what is missing over here is this particular part, as you can see, and whenever you take out something, you find the center of mass of the whole thing minus this thing. That is one way of doing it. Okay, and okay, I have another idea over here. What if I just consider only this part? What if I just consider only this part, which is the remaining part, whose center of mass has to be found, and I say the center of mass is somewhere over here. Now whatever is the x coordinate formula, very similarly I'll get the y coordinate formula. Okay, fair enough. This is the center of mass of the remaining part. Where is the center of mass of this particular part? It will be somewhere here. Now, the figure has been drawn disproportionately, deliberately over here, I think, because if I see where is the center of mass of the entire thing, it will be obviously at the origin. It will be obviously at the origin. It is very disproportionately drawn. It's not to scale, because think about it. This is 2b, this is b. So actually, this should have been the midpoint of this height. Even this is 2a, this is a, this should have been midpoint, but height wise it looks very disproportionate. So what is the center of mass of this guy? Well, this will be nothing but b by 2, and if you ask me what is this will be nothing but a by 2. So if I combine this guy's center and this guy's center of mass, I should get the combined center of mass, isn't it? So if I take this body, which is this 3/4 part, which is nothing but 3m times the mass, and this 1/4 part, let's say I call it m mass, the center of mass of the entire object must lie at the origin. Is this absolutely clear? Is this absolutely clear, my dear warriors? Yes, the center of mass of these two things must definitely lie at the origin. Why 3m and m? Because this is 1/4, these are 3/4. So this is 3 times this particular mass. So let's apply it for the x coordinate first. Let's say x coordinate of the total center of mass will be nothing but plus and plus over here. Here we'll have 3m, and what is the center of mass of this particular part? We don't know, so I'll call it x. Okay, plus this guy, which is m. Center of mass of this guy is nothing but at a by 2, and this is m. But I just know the center of mass is at origin for the entire body, so this is basically going to be 0, which also means that if I take 3m multiplied by x plus m into a by 2, this entire answer will be 0. This entire answer will be 0. Shift this guy on this side, you will get whatever you need. So 3mx will be minus ma by 2, cancels. So x will be minus 2 3s are 6, so minus a by 6. Similarly, same logic if you apply by symmetry. Similarly, in the y direction, if you apply the same logic, the y coordinate will be minus b by 6. So minus a by 6 and minus b by 6, that should be D option. Is that correct? Yep. D option is the correct answer. Very good. Excellent. Beautiful question, isn't it? Moving on to the next question coming up on your screen. There is some mass which is thrown with some speed making angle theta. If the angle of projection is varied keeping other parameters same, then the magnitude of the angular momentum at the maximum height about the point of projection varies as. Okay, so if I throw the particle like this with some speed u, angle theta from the ground, and if I am measuring it with respect to the point of projection at this maximum height, the velocity will be here. If you notice, this is the line of velocity. This is the line of velocity. This is basically that perpendicular drawn. This is the mass. This speed will be u cos theta. U cos theta. So the angular momentum will be m into r perpendicular into that velocity. So it will be m into height into velocity, which is nothing but u cos theta. That is the angular momentum. Okay. Now think logically. If theta is 0, that means it will fall over there. It will just fall over there. Height will also be 0. Everything will be 0. So some special cases if you consider, like theta is 0, height, everything will be 0. So angular momentum will be 0. So the graph must start from the origin. So that is happening over here. Perfect. Now I can see pi by 4, which is basically 45 degrees. So that is the second special case. So theta is equal to 45 degrees. Obviously, it will still reach some height. It will have some angular momentum. So angular momentum 100% won't be 0. So as you can see over here, at 45 degrees, angular momentum is 0. So this option is eliminated. In option B also at 45 degrees, angular momentum is 0. So B option is also eliminated. Luckily at C and D option, at 45 degrees, it is not 0. So at least C and D are remaining as of now. Okay. Now what will happen at another special case? Let's say we take it as example 90 degree. So if we take theta as, let's say, 90 degree, if you take theta as 90 degrees, then what will happen? The maximum height about the point of projectile. See, think about it. There will be no velocity only at the top, because as it goes up, that's it, the velocity at the top will be 0. So the angular momentum will also be 0 when your theta is basically 90 degrees. Yes, it is 90 degrees of projection. So it should be 0 at 90. It is not 0 over here. I can see at 90 degrees, angular momentum is 0. Yes, it was 0 here also, so only D option remains. So by simple elimination, you can get D. Otherwise, you have to use a lot of mathematics to figure out the final answer. Yep, I hope this is absolutely clear, my dear students. Perfecto. Just do it by option elimination, things will be simpler. Moving on to the next question on your screen. The position vector of a particle of mass m is given by x p I cap plus b j cap. That means the x coordinate is changing, y coordinate is a constant. It's going in a straight line parallel to the x-axis. That's what it means. How is the angular momentum going to change? See, this equation clearly has told me the motion, that the motion is uniform, and it is parallel to the x-axis. The motion is parallel to the x-axis. So this is the line of velocity. On this line of velocity, all you need to do is drop a perpendicular. So this becomes your r perpendicular. So the angular momentum is m into r perpendicular into v. This is a constant. This, no matter where you go on this line of velocity, will also be a constant. Mass is not changing. So angular momentum should also be a constant. So everything is a constant. So all the other things are variables. So only option A says that it is a constant, as you can see. Yes, only option A says that it is going to be a constant. Everything else says that it is changing. So definitely option A. In D option, it is increasing. It is not constant. Lot of people make that mistake and say option D. No, it is not option D. Is that clear, everyone? I hope, Aman, that is clear in your head now. Okay, very, very interesting question it was. Next question on your screen. A mouse of mass jumps outside the edge of a rotating ceiling fan. The fractional loss of angular velocity. Okay, so imagine this is a rotating ceiling fan of moment of inertia I. Okay, imagine earlier that mouse was over here. Okay, imagine this particular mouse was over here, and that mouse okay, it has jumped like this. All right, so this was rotating with some omega. Now it has a different omega, let's say call it omega prime. And in this process, what happens is there is no external torque, so angular momentum is going to be conserved. Angular momentum is going to be conserved. So left hand side and right hand side, just write the equations. Angular momentum is moment of inertia into angular velocity. Moment of inertia will be I plus mr square. I is the moment of inertia of the fan, mr square is the moment of inertia of the mouse, will be equal into omega, will be final moment of inertia is only of the fan, only the fan keeps rotating, the mouse is out of the picture, into the new angular velocity. So I think we got the new angular velocity as omega into I plus mr square divided by I. But that is not the question. The fractional loss is asked. So fractional loss is delta omega by omega, which is nothing but omega prime minus omega divided by omega. Omega prime is omega into I plus mr square divided by I minus omega divided by omega. A lot of omegas here. This omega will cancel obviously. So I just have this minus 1. So I just have I plus mr square by I minus 1. That's it. So it will be I plus mr square minus I whole thing divided by I over here. Just check this out. I will go. So it will be just mr square divided by I. So mr square divided by I think it's not kept in the options, but that should have been the answer. The fractional loss of angular velocity should have been this only. Omega, yes, everything is fine. Just check this out. So It is the fractional loss of angular mouse or jumps on the, oh sorry guys, we did the problem exactly opposite. I thought it jumps out of the fan, but the question says it jumps on the fan. Sorry, it was jumping on the fan. So everything will change. So our final will become initial, initial will become final. So you just have to redo the question. Okay, you just have to redo the particular question. So I'll just tell you what will happen in that case. Exactly opposite. So sorry. Same process, but it will be repeated like this. This is exactly opposite. Yeah, this will now be, this will be omega and this will be omega prime, and the mouse has not jumped out of it, rather it is jumping onto it. Okay, like this. So that's all. So it will be nothing but I omega will be I plus m r square into omega prime. So find omega prime and then find delta omega by omega, which is omega minus omega prime upon basically omega. So you will get the answer. And that answer comes out to be as this mr square by I plus mr square. mr square by I plus mr square. I just did the same problem in the exact opposite way. So I did not see this word, or else obviously we would have solved it like this. Is this absolutely clear, my dear students, how you're going to solve this? Everyone? Yep. Perfect. Perfect. Moving on to the next question, guys. Let's, after this, maybe we can do some category 2 questions and then category 3 questions. There are two convex lenses of focal length f and which are placed at a distance of f by 2. An object is placed here at 4f. Then the question is, where is the final image? I think it is just combination of lenses question. So let's do it step by step. Consider only this particular lens as of now. So let's find out where the image will be. So use 1 by v minus 1 by u is equal to 1 by f. V I don't know. Object is at negative 4f. Focal length, both are f only. So 1 by f. So 1 by v is equal to 1 by f. Minus minus is plus, goes on the other side, becomes minus. So this will become basically 4f as the LCM. So 4 minus 1, which is basically 3 by 4f. So that is nothing but 1 by v. So therefore, image distance will become 4f by 3. So 4f by 3 from the lens means somewhere over here. So the image is going to be formed somewhere over here. This is your image which is going to be formed, and this is going to be 4f by 3. Now comes the interesting part. That image which is formed, will now behave like the object, for the next lens. Which lens am I talking about? This lens. It will now behave like an object for the next lens. So how far is that image from the second lens? We need it for the next part of the problem. So how much will this distance be? So if you ask me, that particular distance will be 4f by 3, 4f by 3 minus this distance, which is nothing but f by 2. So LCM is nothing but 6. So this will be 8f minus 6f, sorry, not 6f, 3f, my bad, minus 3f. So 8 minus 3 is basically 5. So it will be 5f by 6. Is that clear? So it is now at a distance of 5f by 6. That will be the new object distance for the next lens. Is this absolutely clear, everyone? Very good. Yes, we'll be making lectures for BitStat also, Chirag, definitely. So this distance, I will write it as 5f by 6. But please remember, this is a virtual object. This is not a real object. It is a virtual object. So if I again use the formula 1 by v minus 1 by u is 1 by f. V I don't know. Object distance is on the positive side, which is 5f by 6. So that is equal to 1 by f. Is that clear? That is what we are going to do. Apply lens formula second time, but with new coordinates, with new origin for the new lens. Okay, so 1 by V is equal to, take it on the other side. So it will become 1 by F minus 1 by 5F by 6. So 6 goes on the top. So LCM is basically 5F. So this will become 5 times. So minus 6, which is that right, everyone? Yep, object distance was on the other side. Okay. Yes. And this was okay. This is also called two convex lenses. Okay, becomes like this. So 5F is the LCM. So 5 minus 6 over here. Okay. Hmm. Oh, sorry guys. I think I made a mistake. This would have been plus. Yeah, that's what I was wondering, or else nothing will match. So this will become 11 by 5F. Okay, so this will be 1 by V. So therefore, V will be nothing but 5F divided by 11. So 5F divided by 11, that is the answer. Now 5F by 11 is there 2 times. 5F by 11 is basically there 2 times. Which one will you choose? Think about it carefully. It is positive. If it is positive, this particular answer is positive, that means it is on the right hand side. So it will be basically on the other side, which is right hand side of it. So basically the answer will be option A. Yes, the answer will be option A, right hand side, because it was positive. Yep. Comed K also, definitely. So see, one thing is very simple, guys. If you put up comments after the lecture is over, then we can take up sessions related to that, because WBJEE, many students demanded for it. That's the reason why we are doing it. Okay, remaining questions you can do it as homework. I will now go to category 2 and then we can go to category 3. We'll just do some category 2 questions. Category 1, again same level only, you will be able to solve it. Just some 3-4 questions I have kept it as homework. Let's go to some category 2. Monochromatic light of certain wavelength is incident separately on the surfaces of 4 metals. The work function of A, B, C, D, R, so and so. The metal or metals where electron will be emitted. That means your energy of the photon has to be more than the energy of the work function. Correct? That is what the conclusion is. The metal has to emit that electrons. So first let's figure out what is the energy of the photon. What is the energy of the photon? It is nothing but 12400 divided by 4770. That is in electron volt. This is the standard formula if your wavelength is given in Armstrong. So 12400 by 4700. Approximately how much will it come out to be? Approximately, just tell me how much is the energy going to come out to be. Comet K is slightly simpler. Yeah, Comet K is slightly simpler. Yes, how much is it coming out to be, guys? This is not going to be 3 times for sure. It is not going to be 2 times also. So it will be somewhere between 2 and 3. It will be somewhere between 2 and 3. It will not be 2.3 also. 47 and 124, right? Take it as 48 only. 48 and 124. 48 into 2, 96, and 24 is somewhere in between. So I think it will be close to approximately 2.5 electron volt. Is it so? Now this is definitely more than 2.3 electron volt, but it is definitely less than 3.2 or 3.7 or even 4.2 electron volt. So in all these cases, photoelectric effect will not occur because the energy is lesser. Whereas in this particular case, it is more than the work function, so it will occur. So which is this element? It is D element. So D element, it will occur. So only D is the correct answer. Only D. Yep. D for dancing rose. Perfecto. Perfecto. Very good. Excellent. Moving on to the next question on your screen. Two metallic spheres of equal outer radii are found to have the same moment of inertia about the respective diameters. Then which of the following statements are true? Two spheres of equal outer radius are found to have the same moment of inertia. The spheres have equal masses. The ratio of the masses is blah blah blah. We cannot comment about their masses so easily because we don't know what is there exactly inside. Just the outer radius are same and the masses, I don't know, but inertia is same. Spheres are made of different materials, we cannot be so sure. The rotational energies will be equal when rotated with, yeah, this is what I can say, half I omega square, which is the kinetic energy. See, if they are rotated with angular speed, omega is the same, moment of inertia is the same moment of inertia. Obviously, their kinetic energy will also be the same. Obviously, their kinetic energy will also be equal. So only D option I can say. Yes, D is correct. Masses maybe same, maybe not same, because only outer surface I know. I don't know what is really there inside. Maybe the masses are different, and that's why the distribution is different. So it ends up compensating and gives same inertia. We do not know anything what is happening inside. So no comments over there. Is that right, everyone? Clear, my dear students? Let's go to the next question on your screen. Here it is. Two charges are there and are placed at A and B, where B is at a distance of D to the right of A. Total potential due to these charges is minimum at P on the line through AB. What is the distance? Okay. So let's say that our charges are Q and 4Q. They are placed at points A and B at a distance D units to the right of A. Okay, so this dotted line is basically D units. And what is happening is the potential due to them is minimum at a point P, which we do not know where it is. Okay, which we do not know where it is. So we'll just assume this particular point as P. Okay, where the potential is minimum. What is the distance is what they have asked from A. That means they have asked basically what is this distance? What is that distance? So one thing is clear, that electric field in general is negative dV by dr. So if we want potential to be minimum, their derivative of that potential with respect to the distance should be 0. Therefore, the electric field at that point must be 0, because dV by dr negative is E. So potential is minimum. So minima. So the concept, the slope must be 0. The slope must be 0. So hence electric field must be 0. Therefore, the electric field due to Q, whatever is there from the right hand side, magnitude wise will cancel the electric field of the charge 4Q, which will come the other way around, magnitude wise. So that's all we need to do. So electric field due to Q will be KQ divided by x square. Due to this guy, it will be K 4 times of Q, but that distance will be D minus x the whole square. Is that right? Now, a lot of things will definitely get cancelled, like K and Q and this Q. Now, take roots on both sides. So, I'll be left with 1 by x is equal to 2. Root of 4 is 2 by D minus x. Cross multiply. So, you will get D minus x is 2x. So, therefore, D is nothing but x plus 2x is 3x. Therefore, x is nothing but D by 3. So, the answer is D by 3. So which is option A. Yes, perfect. D by 3 units to the right of A. Is this clear? Everyone? Yes, Harsha, that is the perfecto answer. Very good, very good, very good. Let's go to the next question on your screen. There is a small ball which keeps bouncing on a plate, and each bounce the speed reduces by a factor which is called as the restitution. We know that E is the ratio of speed of separation by speed of approach. So every time it bounces, let's say E is 0.7, so the speed will become 0.7 the previous speed. Next bounce, it will become 0.7 the previous speed. That's what happens. So if you drop it from some height, after 10 seconds, it stops bouncing. What is the value of E? So there is a direct question which is there in JEE also. Many times you might have seen this question, where if you drop this ball from certain height, then it bounces off to a new height which is slightly less. Next time it is even slightly less. Next time even slightly less. Next time even slightly less, and finally stops. This is basically a converging or decreasing GP series. decreasing geometric progression series. Yes, geometric series. So even the height and even the time, whatever it is, height or the time which it takes is basically a decreasing GP series. So the total time to stop will be the sum of that GP, which is infinite, of that infinite GP. Yes, sum of that infinite GP, because there will be infinite number of collisions. Infinite number of collisions, because every time the speed is reducing by a factor. If it becomes point, say 7 times, next is 0.7's 0.7, next is 0.7's 0.7's 0.7. So it is never equal to 0, it is tending to 0. So some small speed is there, eventually the speed becomes tending to 0 and you say it has stopped. So after summing up that infinite GP, there is a formula that you get. Anybody remembers that particular formula? Anybody remembers that particular formula? If you have solved the questions before this, you would remember it. Yes, what's the formula, guys? See, it is root of 2 times height by g. Here you put 1 plus e outside the root upon 1 minus e. So this is the formula after summing up that infinite GP. So here the height is already known to us. Height is basically 0.4. Root of, sorry, height is 0.4 and time is how much? Time is basically 10 seconds. So time is 10 seconds. So root of 2 into 0.4 divided by g, which is 10. 1 plus coefficient of restitution. Oh, that is what is asked, upon 1 minus e. So what we can do is 2 into 0.4 is basically 0.8. Is that right? It is basically 0.8. So 0.8 is nothing but 8 by 10. So this will become 8 by 100. Okay, upon 1 plus e by 1 minus e. So root of 8 is 2 root 2. Root of 100 is basically 10. 1 plus e by 1 minus e. So this 2 and this 10 will cancel, become 5. So 1 plus e by 1 minus e will be 50 by root 2. Will be 50 divided by root 2. Use the principle of componendo and dividendo. So it will become 1 plus e, which is the numerator, plus 1 minus e, which is the denominator, upon 1 plus e minus 1 minus e. Same thing you do over here. So 50 plus root 2 by 50 minus root 2. So here you will get basically 1 or 2, 1 plus 1, sorry. And here you will get e plus e is whatever it is. So it will be 2 divided by 2e. 2 cancels. It will become 1 by e. So basically e will be nothing but 50 minus root 2 divided by 50 plus root 2. See how much approximately the answer comes out to be. I think it will be close to 1, but not exactly equal to 1. This is not equal to 1. This is not equal to 1. This is not close to 1. This is very close to 1. So I think approximately it will come close to 17 by 18 after solving it. Yeah, because this number 50 minus root 2, which is almost like 1.414. So it will be like 48.6 or something, and this will be like 51.4. So when you take the ratio, very close to 1. So I think D should be the answer. Yes, D is the right answer. Okay. Is it absolutely clear? I didn't take the SRM-JEE mock test. How can I write? Don't worry, Divya. You can give some extra mock tests right over here. As you are watching this particular video, I have kept some mock tests. Please, first of all, you guys not liking the video, it is very bad, guys. Smash that like button right now. You can see WBJEE test series link is there. You can give this particular test series. It's just there for 650 rupees. Yep, you can give 10 mock tests. But let's say, sir, I want ComEdK test series. It is there here. But sir, I'm going to give multiple exams. Then you can buy all the test series together. WBJEE is there, MHTCT, blah, 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 VIT EEE, SRM-JEE, Amrita. All of this for 1,299 rupees. Yeah, everything is there in this. All the entrance tests. ComEdK, BitSat, okay, everything, WBJEE, everything is there in this. So you can check that particular link out, which is there in the description box. Is this clear? Yep. I just want to study hard, but I want to crack 2026. Please, can you guide me? Yes, Sunita, I will do one thing. I'll be making a separate video for all of you very soon for 2026 roadmap. Just hold on for some time. Okay, cool. Let's go to the next question coming up on your screen. A body floats 1 by nth volume keeping outside the water. The body has been taken to height h inside the water and released. Okay, so let's assume this only is the water surface, and let's assume this is that body. Okay, let's say the total volume of the body is V and the density is sigma. So 1/nth is outside. So 1/nth is outside. That means this particular volume will be V by N. Whatever is inside the liquid will be V minus V by N. Okay, this is basically submerged. This is basically submerged. Now, when I say submerged, what is the density of the liquid? It is rho. This is the density of the liquid. So when this happens, we all know that the weight of the solid, which is mass into gravity, mass is density into volume. This should be equal to the buoyant force. And the buoyant force formula is volume which is submerged into density of the fluid into G. Volume submerged is V minus V by N. Density is rho, G is G only. Things like G and G, V get cancelled. So I am left with sigma is equal to rho into 1 minus 1 by n, which I can also write it as n minus 1 by n. So this is the relationship between density of solid and density of the fluid, where n is some number which is in the air, which is deciding the fraction which is in the air. Okay. Now the question is, if you take this particular body, just imagine you take this body deep inside. And this is now at a distance of h. And you release it. Obviously, it will accelerate up, and by the time it reaches the surface, it will have some velocity. Question is, what is the it will come to the surface after time t. Oh, it will have some velocity at some time t. So what is the time that it takes to reach here? In order to find that out, what is the best way we can do it? It is taken down by some height, and we have to find the time basically. Use S is ut plus half at square. Is it right? So use S is ut plus half at square. From here, you are basically releasing it. So displacement is h, initial velocity is 0, acceleration I do not know, time I have to figure out. What is the acceleration going to be? Well, one thing is clear. For any such body which is submerged, in order to find that acceleration, upward force will be the buoyant force, downward force will be the weight, will be mass into acceleration. Buoyant force, it is completely submerged, isn't it? So it will be total volume into total density into G. Weight is total density of the solid into the volume into G. Mass is density into volume. This is basically your A. Volume gets cancelled everywhere. So A will be rho by sigma G minus sigma, which is that right? Rho by sigma, and sigma by sigma, that is just going to be 1. So minus G, that's it. So it will be nothing but G into rho by sigma minus 1, which I can write it as, see guys, rho by sigma. From here only you can get it. What is rho by sigma? N will go on the top, and n minus 1 will be below, and this minus 1. So this will be nothing but G into n minus n plus 1, whole thing by n minus 1, and n cancels. So it will be G divided by n minus 1. So that is the acceleration, which is g by n minus 1. Till this point, everything is clear? Okay. Now take this and put it over here. So acceleration is g by n minus 1. So what do I get? Question is, time is proportional to what? So as you can see from here, t square is inversely proportional to n minus 1. Sorry, not inversely, directly, because n minus 1 will go on the top, is directly proportional to n minus 1. This means time is directly proportional to root of n minus 1. So time is directly proportional to root of n minus 1. If you take n minus 1 here, t square is proportional to n minus 1 in the numerator. So time is proportional to the root of that. So D option is the right answer. It is a brilliant question which has been framed. Yes, it is a brilliant question. Very good. Excellent. Let's go to the next question on your screen. Here it is. Water is filled in a vessel. Hole is made at a height z as shown. The value of z for which the range of the water is maximum. This is your Torricelli's law. If you remember, Torricelli's law. And the range, if you remember, comes out as a root of 4 into h minus h into h and all of that. And we see that if you drill a hole here, maybe the water will fall here. If you drill exactly at the same height from the top, it will have very little speed and it will just fall exactly at the same spot. Then if you probably drill it somewhere here, it will fall here. Same height from the top, maybe it will fall here. Speed is more, longer time. Speed is less, sorry, but longer time. So falls exactly there. And exactly in the middle, if you drill it, it will fall at the maximum distance. Maximum distance. And this is always in the middle. So it is at h by 2. So like for projectile motion for complementary angles, the range is same. Here for complementary heights, that means if 1 meter from bottom, 1 meter from the top, her range will be same. 2 meters from bottom, 2 meters from top, range is same. In the midpoint, the range is same whether you measure it from top or bottom, and it is also maximum. So it is basically h by 2 directly. It is basically h by 2. Yes, not h by 4. Lot of you made a mistake there. Okay, let's go guys to category 3 questions now. Yes, there are some category 3 questions. These are some tricky, difficult questions which will suck away your time. All right, so let's have a look at the first question on your screen. There is a rod which is of length AB, mass 4 kg, 1 meter is the length, and they are resting on the smooth walls, vertical and horizontal. Velocity of A and B points are 3 and 4. Then which of the following is true? Velocity of center of mass, instantaneous axis, angular velocity, clockwise or anti-clockwise. Okay. So one thing is sure, that because instantaneous axis everything is asked, observe this. Whenever you have a body and you know the velocity of any two given points, just drop a perpendicular to those velocities and see where those velocities intersect. See where those velocities intersect. Wherever they intersect, that is basically your instantaneous axis of pure rotation. So if any body is there, you know any two random points velocities. Even if you don't know the magnitude, it's okay. If you just know the direction, that's enough. Just draw perpendiculars, because about the axis of rotation, all the points will go in a circle. So that is the reason why all the points going in a circle means those perpendiculars become the radius. And radius is always perpendicular to the velocity. That is the thought process. So the axis of pure rotation is here. So it says axis of pure rotation is point O. No, it is not point O. So B option is obviously eliminated. Now about this point O, all the points rotate. So let's say this will have some omega, even this point A will have some omega, and this length, how much will it be? Well, we do not know. So let's just assume these lengths over here. Let's say I call this Y and let's say I call this X. So omega, we all know, is there a, well, luckily it was there. I could have just done it on the next slide, but it's okay. So omega, V is omega R, omega is V by R, omega is V by R. So for point B, the velocity is 4. For point A, the velocity is 3. The distance for B is basically x. So 4 by x. And for 3 meters per second point A, the distance is basically y. This is what it is. So 4 by x is nothing but 3 by y. Everyone, till this point, absolutely clear? Everybody, till this point, absolutely clear? Very good. I am getting some ideas now. If I write down x value, and if I write down y value, how much will it be? X will be omega, no, x will be 4 by omega. Omega will be below, and here I will have 4 and here I will have 3. So why not do x square plus y square? X square plus y square, because what is x square plus y square? It is this length, which is basically 1 meter. It is clearly given. So this is basically 1. So on the right hand side, we will have 4 by omega square plus 3 by omega square. 4 square is 16, 3 square is 9, the whole thing by omega square. So omega square will be 25, or omega will be 5 radian per second. Oh, interesting. We got the value of omega, which is 5, but clockwise or anti-clockwise? Omega is anti-clockwise, so anti-clockwise means option D. Automatically C goes out of the frame. C goes out of question. Is this clear, everyone? Okay. Now the only option remaining is velocity of the center of mass. To find any other point's velocity, again just drop a perpendicular. This is exactly where the center of mass will be. The center of mass will be, and center of mass will have a velocity perpendicular to that distance, that you are drawn, because all the points will be rotating in circles about this point. So any point you take, just drop a perpendicular, velocity will be like this, because everything is going in circles. So if I call this VC, I just need to know this distance. I think we can find it. See guys, this whole distance would be 1. So I think this distance will be 0.5 meter. This distance will be 0.5 meters. Why this distance will be 1? Why? Because this is also 1. Symmetry is there. So VC will be omega into that distance, whatever it is. Omega is 5, distance is 0.5. 5 5 are 25. Put the decimal. So 2.5 meters per second, which is correct. So A option is right. Is this absolutely clear? Why the distance was 0.5 meters? I've explained it to you. Cool, guys. Shall we go ahead to the next question coming up on your screen? Shall we go ahead to the next question? So this kind of questions will definitely take some time. Around 3 minutes you can keep it. Let's check out. Yes, A and D are correct. B and C are wrong. B and C were definitely wrong. Okay, this slide not needed. Moving on to the next question. A particle is moving in the xy plane given by this equation. Omega is a constant, which are true. E by omega is a constant, E is energy, trajectory of the particle is a circle, velocity is not perpendicular to the position R, A is equal to omega square V. Okay, let's think. First of all, this equation looks very familiar to me for some reason. Just observe this. This is x-axis, this is y-axis, B cos omega t and B sin omega t. Okay, how about this? Imagine this is the vector, this is that particular vector B, okay, and this particular angle is nothing but omega into t angle. So the base will be nothing but B cos omega t, and the height over here will be B sin omega t. Oh, so it is basically referring to a point over here whose horizontal component is this, vertical component is this, but B is not changing. Omega t will keep increasing. That means that particle, what will it exactly do? That particle will definitely go in a circular path. Yep, that particle will definitely go in a circular path. This is how the velocity will be. And the centripetal acceleration will be existing. The acceleration will be towards the center. This is what it is. So the trajectory of the particle is a circle. Definitely this is correct. And because speed is constant, energy will be constant, omega will also be constant. So this will be also constant because energy, which is half mv square, will also be a constant. And already it is mentioned omega is a constant, so you don't have to worry about omega. So that ratio will definitely be a constant. Velocity is not perpendicular to the position. Definitely it is perpendicular. As you can see over here, the velocity is actually perpendicular to the position. So it says it is not perpendicular, it is wrong. Acceleration is omega square into r. Omega square into r, not velocity. So definitely this is also wrong, because we know our acceleration will be omega square into radius. Radius over here will be b. Here they have said v. So this is also wrong. So A and B should be the right answer. A and B are the right answers. Okay. Okay. Same concept. I have very good luck. I'm so glad that your VIT Triple E went well because of our VIT Triple E mock test conducted on the channel. So glad, my dear. Awesome. Awesome. Moving on to the next question coming up on your screen. Okay. Here it is. A hemisphere of radius r is placed in a field so that the axis is parallel to the electric field. Which of them are true? Flux to the curved surface, flux to the circular face, total flux is 0. Work done in moving a charge from A to B via path ACB depends. Oh, first thing, though, directly I can mark D as the wrong answer. It says it depends. It is independent because electric force is conservative force. Whenever you have conservative force, the work done should be independent of the path. It says depends. So automatically D option is wrong. Everyone understood why D option is wrong? Okay. Next one. Whatever surface is there over here, okay, which is the base, the flux is entering inside over there. The flux basically enters inside the circular base. The circular base is entering inside. So definitely it will be negative. Similarly, if you consider the curved surface, if you consider the curved surface, the same field lines are going out, the curved surface, the same field lines are going out, and it will be positive. If you count the net flux, if you count the net flux, it will be basically a big fat 0, guys. It will be a big fat 0. So total flux is 0. That is correct, because whatever lines enter inside will exit outside. So no net flux is there. Yeah. Whenever flux enters in, it is negative. Whenever it exits out of a closed surface, it is positive. So net is 0. So magnitude wise, they are equal. So flux which is coming through that circular face, you can just say magnitude wise, it is nothing but pi r square, which is area, multiplied by the field. Okay, this is just magnitude of it. This is nothing but the area of it. So this is the magnitude of that particular flux. So the flux through the circular face of the hemisphere, and this, how much will it be? Let's figure it out. So on the circular face, it is coming inside, so it will be minus pi r square e. So the circular face is minus pi r square e. No, it is not given minus, so I'll mark it wrong. But the flux which goes out from the curved surface, magnitude wise it will be the same, but sign wise it will be opposite. So it will be pi r square e. Yes, this is correct. Why B is wrong? Because that minus sign is not there. So A and C should be the right answer. Let's check it out. A and C, yes, perfect. See guys, you have to be very careful with the signs. One small thing goes wrong, you are going to get it wrong. Signs were very important. Sign, yep, very important. Cool. Let's move to the next question on your screen. A magnetic field is there. Magnetic field is there. One second, one second. An electron of charge q and mass m is moving with speed, enters the region perpendicular to the magnetic field considering Bohr's momentum. Wow, they have considered two chapters now in the same question. Which of them is true? Radius, speed, energy, potential energy is 2 times of kinetic energy. I think this though directly we can say, if you remember, usually what happens, energy, total energy is negative of kinetic energy, and total energy is 2 times is nothing but potential energy. Just check this out. These were the usual formulas. So if I put E over here as negative K, E over here as negative K is nothing but U. So potential or negative 2 times of kinetic energy, negative 2 times of kinetic energy is potential energy. That is definitely D option. That is definitely true. This is something which you have learned in the chapter of atomic structure. Even in gravitational chapter, you have studied this concept, right? Satellites, the total kinetic energy, total potential energy, how are they related to the total energy of the satellite, or even for the electron? So D option is very obvious. Now we have to figure this out, but you cannot say this directly because this is not exactly the same Coulomb's law which is applicable now. It is in a magnetic field, so it is the magnetic force which is driving the circular motion. So if I consider that charge which is basically going in a circular path, this is your charge, this is having some mass, there is some radius, then there is some magnetic field also, there is some magnetic field also. Okay, so how are these speeds, everything related to each other? We know very simply the radius is nothing but mass into velocity divided by charge into magnetic field. Okay, everything fine till this point. But they have also mentioned that Bohr's angular momentum quantization is valid. Bohr's angular momentum quantization is valid means angular momentum is n times h by 2 pi. And I can see in the options some h and all that is also there. Okay. Angular momentum is mvr, and that is nothing but nh by 2 pi. First things first, we have to get rid of velocity and find radius. Okay, so mv I can see from here only. mv is nothing but rqb. So just substitute, instead of mv, just substitute it as r, q and b. This r is just there over here still, is equal to nh divided by 2 pi. Okay, perfect. So I will get r square is equal to n h by 2 pi, and this r square is there, and qb will come below. So 1 by q into b. So therefore, what is radius? Radius will be root of n by qb, n by qb. What is this h by 2 pi? I can use this symbol h, that dash, that h dash which is there is nothing but h by 2 pi. Yes, you should know this. Planck's constant by 2 pi. Yep, that is h dash. Yes. So therefore, r is root n h dash by qb. Root n h dash by qb. Yes, radius is definitely proportional to root of n. A option is correct. You can see it right from here. Radius is directly proportional to root of n. But that's not the final answer. We have to find out energy also and minimum speed also. A lot of things are there. So let's go to the next part where we find out about the velocity. So from velocity, we can use this directly. Okay, we can directly use this m times v is equal to r q into b, because this is what we had substituted over here also, if you remember. Okay, So velocity is nothing but RQB divided by M. R is nothing but this whole nonsense. So root of N H dash QB, and there is QB over here, the thing divided by M. So therefore, velocity will be root QB will cancel. I'll be left with N H dash QB. That's it. Yep. So everything is in the numerator only. N H dash, and we have Q into B. And the whole thing is just divided by the mass. But since we want minimum velocity, that will happen when N is 1. So that will be root of H dash QB, the whole thing divided by M. That is when N is equal to 1. Minimum speed they have asked. So the minimum speed when N is equal to 1 will be root QB H dash by M. Root QB H dash by M. Perfect. This is also correct, guys. The only thing left is energy now. The only thing left is energy. If you find kinetic energy, automatically potential energy, total energy, everything you will find automatically. So let's find out the kinetic energy, because I know the total energy is negative of kinetic energy. Kinetic energy being half mv square. So this will become negative half mv square. So negative half, mass is mass, speed is basically this whole thing. So root of n h dash qb, the whole thing by m, and this is whole square. So this is going to be, this is going to be, this is going to be nothing but m by 2m square n h dash qb. So as you can see, the energy is directly proportional to negative n. Yes, energy is directly proportional to negative n, which is what was needed. Which is what was needed in the question. Energy is directly proportional to n, so C option is also correct. C option is also correct. Is this absolutely clear? Beautiful question, isn't it? Everybody? Everyone? Perfecto. Shall we go ahead? Yes. So let's see. I think what is happening over here, A, B, C, D. Oh, everything is correct. And it is what it is. A, B, C, D. All the options were correct. So such type of questions usually take a lot of time to solve in the actual exam. Let's move. There is a particle of mass m charge q moving with some speed enters a region of magnetic field. Boundaries are shown. Region has a uniform field perpendicular to the plane. Also, region has some length L. The particle enters only if this is the condition. Particle path of the particle in region B is a circle. Time spent is independent of the speed. These are very, very interesting questions. These are very, very interesting questions. Very good. Yes, alter ego. Yep, that is correct. Okay. Now, you might have solved these kind of questions before also. If I have some, yeah, diagram. Okay. So it so happens that if the speed is very, very high, right? If the speed is very, very high, then before it completely turns around, it will exit into the region C. If the speed is just sufficient enough so that what happens, it becomes tangential over here and then returns back over here like this, and you will see then it will return back from here. This is another possibility. And if the speed is even higher, sorry, lower, my bad, if the speed is even lower than this, then you will see something like this happening. If it is lower than this, it will go like this, and then it will come out from here like that. So this is how the scenario is when the speeds are less. So this is when the speed is less speed, and this is the situation when there is basically a very large speed. And when it is a critical speed, it just touches, grazes through the boundary wall over here. It just grazes through this boundary wall over here and it comes out. And in such a case, you will notice that the radius of the circular path the radius of that particular circular path. This is basically the radius. This radius happens to be the length. So the radius happens to be the length, and radius is mv by qb, which is L. So V is basically LQB divided by M. So when the speed is more, that means when speed is more than LQB divided by M, then it enters into region C. But when the speed is less than LQB divided by M, then it comes back into the region A. So if you look at the options, also given region B has length L, region B has uniform magnetic field. Okay, enter B along the normal as shown in the figure. Particles enter region C only if the speed is more than something. This is exactly what is given over here. It enters region number C if the speed is more than LQB by M. LQB by M. Yes, so this is correct. This is obviously wrong, because if this is correct, this has to be wrong. The path of the particle in the region B is circular. Yep, all these paths are circular. That is what magnetic fields do to charged particles which are put in perpendicular inside of this. So obviously, this particular option is definitely correct. Yes, this particular path is always going to be uniform circular motion. What about the time which is spent in region B? In case you want to find the time which is spent in this region, that particular time is half the time of the revolution. So time for revolution is 2 pi m by qb. 2 will get cancelled. As you can see, it is independent. Of the velocity. And there is no velocity in it. So over here, the time spent is independent of the velocity. That is also correct. So A, C, and D would be the right answers. Yep, A, C, and D will be the right answers. Is this absolutely clear? Everyone? Perfecto. Okay, that was the last question which we had in today's session. And some of the category 1 questions, like I said, few questions I'm going to give you as homework. All right, the entire PDF will be available as a link which is there in the description box or in the comments. So please download it and solve the questions. And I would advise you to not watch the solutions until you have tried it on your own. So that will give you a push to better understand those questions and solve it on time. And only take hints from the video lecture. Okay. So I hope you enjoyed the class. Share this video with all the students who are going to write the WBJEE entrance examination, and any other entrance exam that you're preparing for, please let me know. 2026 students, something great is coming for you. So stay tuned. Bye bye. Have a great time. Take care.